Welcome to Study Loop.
Hi everybody. So what is the moment of inertia of the wheel? This is a rotation of rigid bodies question, okay? And from this, we got to find the angular displacement of the wheel, and then we have to find the rotational kinetic energy of the wheel, relation between angular acceleration, angular displacement from the equations of kinematics, angular velocity, and then we execute all this to find what we need, okay? So here we have the initial angular velocity is going to be at 0 radians because it's not moving, it's 0. And then we have the angular displacement of the wheel at 8.20 revs. And we're going to change this to radians per second. So what we're going to do is just times this by 2 pi radians divided by 1 RV. Okay. And here we have 51.496 radians. And time taken is equal to 12 seconds. And the kinetic rotation of the wheel is going to be 36 J's or joules, okay? And now we have the equation that we're going to be using. So we have initial t plus 1/2 t squared. We know this is going to be 0. And what we need to do is solve for this guy right here. And we get 2 pi t squared. Okay, and we're just going to leave this how it is. And we'll leave that right there for right the second. And now we have to do the angular velocity at W2 after time of t. Okay? So that is just this equation. And we're going to plug this into here. And here we get 2 pi. Oops, it's not equal here, it's plus. Look at me. And t. Okay? And we know that this is 0. And what we have to do is just worry about this little guy here. So we get 251.496 radians divided by 12 seconds. And we get 8.58 radians per second. Okay. And now what we're going to do is rotational energy of the body. And so we have your K, 1/2 I for inertia, and your angular velocity, the second one. And now we're going to solve for your I, because remember, we know what this is, but we don't know what this is. That's one way to help figure out what you need to find. Okay? I'm just going to move it around. There we go. Because we wanted to find the inertia of the wheel. And 236.0 J kinetic energy over 8.58 radians per second squared. And what we get is roughly 0.98 kilograms times meter squared. Okay? And that is your answer, guys.